G'day ladies and gents, Cubic Media here with the eagerly awaited update to the Orbital Strike Cannon. This is the Orbital Strike Cannon 6, which has been fully designed from the ground up in version 1.21.4 of Minecraft Java Edition, and will work on any version of Minecraft 1.21 or above. In case you're wondering what happened to the 5.0 version, well, this is the 5.0 version, and as you can see, there's something slightly wrong with it. Yeah, in 1.21.4, merging happened to change something about entities interacting with honey blocks, and it completely broke the alignment system. So I just scrapped the entire thing and started again from scratch, making the 6.0. And as you can tell from the intro, this thing is an absolute beast. I spent 2 months fine-tuning this design to offer all of the functionality and features to make it the ultimate Orbital Strike Cannon. But before we get into the cannon and its design, I think we should take some time to establish some things. It has come to my attention that a lot of people are having a lot of issues trying to get my older designs to work. And I mean, I get it. I was once that kid witnessing some mind-blowing contraption in a YouTube video and wanting to mash that thing into my Minecraft world as quickly as possible, without any consideration for how bloody complex the thing is. So before you go down into the description and smash the download link, perhaps consider smashing that subscribe button, and then listening to me carefully as I walk through the process. To start with, you need Minecraft Java Edition. Not Minecraft Bedrock Edition, not Minecraft Pocket Edition, not Minecraft Winnie the Pooh Edition, and no, I will not be making the Orbital Strike Cannon in Bedrock Edition. It's basically a completely different game to Java Edition, so you may as well be asking me to make the Orbital Strike Cannon in Fortnite. Although, I wouldn't put it past their marketing team given how little dignity that game has left.
My awesome smaller son will now hit the gritty just for you.
If you're wanting to hop onto your generic multiplayer server and build the Orbital Strike Cannon to exact world domination over your online friends, well, there are some things to be aware of first. This is the cannon's alignment system on a vanilla server. As you can see, it works perfectly fine. This is the cannon's alignment system on a 1.21.4 paper server. And as you can see, it doesn't work fine. Unfortunately, paper seems to do something mysterious to the way entities move, which means a finely tuned mechanism handling hundreds of TnT per second will experience some problems. And in fact, this is the problem with trying to build any finely tuned redstone contraption in an environment it was not designed for. Mechanics are changed and the thing doesn't work anymore. The Orbital Strike Cannon is made using vanilla redstone mechanics from the vanilla game. And even the tiniest modifications to these mechanics will cause the entire thing to violently disassemble itself. So needless to say, no, the Orbital Strike Cannon does not work on paper servers, and no, I will not be making an Orbital Strike Cannon to work on paper servers. And the same goes for any fork of paper, spigot, velocity, folia, purpur, forge, you name it. If you're unsure and want to know if the cannon works in a specific environment, well, try it and see. I personally designed the cannon on a fabric client with technical utilities like Carpet, Carpet TIS editions, Chunk Debug, Item Scroll, Litematica, and Tweakaroo. I also use optimization mods such as Lithium and optimized fast entity movement from TIS Carpet editions. That last one is particularly important. If you recall my investigations from the video Learning the Ways of the Wind in Minecraft, you will know that the movement method for entities will make this corkscrew pattern for each tick and only collide with blocks on the independent motion axes. The reason why Minecraft does it this way is because it is more efficient to compute the collisions for each face of the entity independently than it is to brute force the collisions in a straight line. Case in point, my Manum simulation of Minecraft's movement method can't even decide which faces should be rendered when I move the object in all axes simultaneously. So the corkscrew motion is simply easier to implement and faster to compute. Or at least it should be in theory. But there is a problem. To illustrate the problem, let's fire a shot from the Orbital Strike Cannon on a server that is not running any optimizations. Let's start by running a profiler, like so. Fire the shot. And the server will freeze for some significant amount of time. Oh. Rubber banding. And we're back to normal. Here is the result from our profile. If we look at the MSPT widget, we can see that there was a single tick which took 13 seconds to be processed. For reference, a Minecraft game tick usually takes 50 milliseconds or 0.05 seconds, giving us the normal 20 ticks per second of Minecraft simulation. However, with a game tick of 13,200 milliseconds, that means for a single tick the game was running 264 times slower than usual. Down here we can start breaking down the code execution into a tree, and if we follow where the majority of the processing is going, we eventually get to the entity list. Inside the entity list, have ticking the entity, and we eventually reach the entity movement method. Inside the movement method, we have this adjust movement for collisions. And this is where the majority of our lag is coming from. What could the movement method possibly be doing that takes 13 seconds just to fire the orbital strike cannon? To be more concise, 13 seconds to fire a shot containing 171 TnT only 100 blocks away from the cannon. Here is the cannon, and just over here, it's a payload that took 13 seconds to move. What the heck is happening to make that distance take 13 seconds of computations? Well, consider what the computer running the game has to do to check whether an entity collides with a block. The method is known as Simple Axis Aligned Bounding Box, or AABB, which is a very simple computation for determining if two axis-aligned bodies intersect. An entity in Minecraft has a motion tag with values for X, Y, and Z. As the entity moves along each axis, block faces which intersect the entity's hitbox are flagged for collisions. Ideally, this method's computation time would scale by a factor of 4 for each motion value. However, what the game really does is collect block faces in the total enclosed volume of the motion axes, despite the fact that most of these blocks will simply be ignored as the entity corkscrews around them. The result is that the computation time scales with the cube of each motion value. Going back to our original test firing, we can plug in the stats and find that 171 TnT traversing what is effectively the minimum range of the cannon will produce 1.84 billion collision checks. But computers are fast, like really fast. The axis-aligned bounding box formula requires only 4 floating point comparisons, which would take the average computer from 1 to 10 nanoseconds to compute. But even billionths of a second add up over 1.84 billion computations, to give from 1.84 to 18.4 seconds of total compute time. And funnily enough, our 13.2 second lag spike is smack bang in the middle of that range. If only the necessary collisions were processed, we would instead be looking at around 1588 of these collisions taking around 8 microseconds to compute. And that is exactly what Optimized Fast Entity Movement from TAS Carpet Editions implements. So if you're wondering why your game freezes when you fire the Orbital Strike cannon,
Did you prematurely blow it, bro?
Server lagging?
Right?
Server's lagging like crazy.
I am having a massive lag spike.
Hold on.
Oh, it worked.
Holy crap.
what?
He teleported. I don't know. He just disappeared. He said, "Oh, wait, I got timed out." What? Did he crash the server, or is that?
It's because Minecraft's movement code is dumb and stupid and will waste literally billions of computations doing absolutely nothing. If I were a Mojang developer watching this video, I'd probably have a brain aneurysm trying to comprehend those 1.84 billion bounding box checks. And that was only the minimum range of the cannon. The max range of this cannon with the encoders fully maxed out is about 250,000 blocks. which results in over 30 quadrillion collision checks taking about 5 years for the average computer to process. Now I have made a bug report on the issue, so if you think that it's important for merging the fix, be sure to upvote the issue on the bug tracker. You can find a link to this issue down in the description. But that leaves us with a very unsatisfying answer to the question of, does the Orbital Strike Cannon work in vanilla? Because the answer is yes, the cannon works in vanilla. But also no, it will brick your computer with collision checks if you try to fire the cannon in vanilla. Hopefully Mojang will fix the underlying issue, but for the time being we'll just have to modify the game with optimizations such as optimized fast anti-movement. Alright, now that we've established what game we need to play and why that game kind of sucks, you will want to set up the cannon in a creative world and try it out for yourself. You will need to use Litematica, which is a schematic rendering mod for Minecraft. I will not be doing a block-by-block tutorial because, as we've already established, Mojang often breaks things, forcing changes in our designs. And a block-by-block tutorial cannot easily be replaced by the new design. However, with schematic files, all you need to do is swap out the download links and suddenly you have the latest design. Like, just imagine for a moment, if Mojang had to push updates by making line-by-line coding tutorials showing players how to add features for a new Minecraft version. Of course, like any competent development team, they give you a program which allows you to implement any Minecraft version automatically, which is pretty much exactly what Litematica does for redstone builds. But unfortunately, Litematica still has some fundamental limitations. To demonstrate these limitations, here I am in a creative multiplayer server with a schematic of the Orbital Strike Cannon. Litematica is configured to paste the schematic in the world, and when I actually go to execute this pasting, you'll notice that Litematica immediately goes and spams the chat with a whole bunch of fill commands. And while this is happening, it's gradually pasting in all the blocks in the schematic. However, all the redstone is basically disintegrating as it's pasting in. However, if I join a single player world and do exactly the same thing, the entire build pastes in pristine condition. The reason why this happens is because on a multiplayer server, the machine where you play the game is fundamentally separate from the machine where the game is simulated. So when I tell Litematica to paste in the schematic on the server, it will start throwing a bunch of fill commands at the server for each block in the schematic. For example, on my vanilla unmodified 1.21.4 multiplayer server, if I run a fill command through this command block to paste a line of observers, you'll notice that the fill command will actually update the observers, causing them to be powered. If I change the fill command to instead paste something like redstone wire, you'll see that the wire instantly breaks because there's no supporting block underneath it. With this in mind, it's easy to see why fill commands sent by Litematica on a vanilla server would cause complex redstone contraptions to implode. Amazingly, however, in the latest snapshots of 1.21.5, there was recently implemented an extra tag that you can apply in a fill command called strict, which will actually eliminate these erroneous updates when you use a fill command to paste in redstone components. So hopefully Litmatica's fill updates will no longer be an issue on vanilla servers going forwards. But that still leaves another big problem with Litematica: containers. A block like a chest which is full of items will have a fill command which includes its inventory contents as a data tag. But Minecraft's chat has a limit of 256 characters, meaning I simply cannot run this fill command through my chat window. This means that Litematica will simply ignore updating the inventory contents for containers with large amounts of data. However, this isn't a problem in single player worlds, because in single player, the client and the server are running on the same machine, and therefore Litematica can directly access the game's memory and modify the inventory contents that way. So if you are wanting to do a quick and dirty test of the Orbital Strike Cannon, ideally you would use a single player creative world where you can paste the schematic in directly without any issues. If you are absolutely needing to test the cannon on a creative multiplayer server, then you will need to install a mod called servux, which enables Litematica to upload a schematic to the server so the server can paste the schematic into the world. And it actually works really well. But of course, you will need access to the server files to install the mod, so this option is only really available to people who own the server they are testing on. So pretty much, if you want to build the Orbital Strike Cannon in multiplayer, you will at least need a fabric client with Litematica so you can use a schematic to build the design. Then the server would need to be fabric, with carpet mod and TIS carpet additions to implement the optimized fast entity movement. However, if Mojang decides to fix the issue with collisions, this requirement would no longer be needed, meaning you could build the cannon on any vanilla server and not have it crash the game. If your server is fabric, then I would also suggest mods like Lithium for gameplay optimization, and of course servux if you intend to paste the cannon with Litematica. So now that you have the required optimizations and Litematica for rendering schematics, where do you want to actually build the cannon? This new design has fully omnidirectional firing, and so there is no need to rotate the cannon, and I would suggest not rotating the cannon because I have not tested whether it actually works in different orientations. Where you build the cannon will have an enormous impact on how effective it is, and there is a trade-off between stealth and speed. A cannon that is over 100,000 blocks away from its target will be more difficult to locate. However, each shot will take over an hour to charge. On the other hand, a cannon that's only 4,000 blocks away from its target will take just over 3 minutes to charge, but is more likely to be loaded accidentally by players wandering around or even looking for the cannon. So you will need to strike a compromise between the time it takes to fire a shot and the likelihood of a player wandering into range. But fortunately, this design has a couple of features to make this decision much easier. First of all is my decision to omit using any block entities which stand out on the F3 debug screen's pie chart when listing block entities. This is a common method that tryhard players will use to locate bases on multiplayer servers. And as you can see, the only block entity from the Orbital Strike Cannon which shows up here is the chest. But then wouldn't players be able to locate the cannon using the chest? Well, if you go onto a Minecraft world with natural terrain generation, dungeons will generate naturally with chests in them, making the cannon completely indistinguishable from naturally generated terrain. It might be possible to locate the cannon using the entity pie chart. However, I will leave this as an activity to the viewer to decide if this is a practical means to use in survival. Another useful feature is these trapdoors, which will automatically detect when the player is no longer loading the area, and open, allowing the payload to escape the magazine of the cannon. These trapdoors will enable the cannon to conceal itself whenever the player is nearby, and then open automatically when the player leaves, allowing the cannon to fire. One unfortunate problem with using this trapdoor is that it will kill grasses, leaving a trace of where the trapdoor is when it closes. So open plains of grass are probably not a very good place to build it. Forested areas are great because the canopy can help obscure the cannon. However, a player on foot is unlikely to miss the obvious signs of a trapdoor. This mangrove swamp is an amazing location because the dense canopy combined with a block that does not decay like the grass creates the optimal conditions for concealment. However, keep in mind, if you are too selective about where you build the cannon, somebody else could follow your logic and use it to refine their own search for the cannon. Unfortunately, one of the places you cannot build the cannon is underwater, because the daylight sensors that we use for the wireless redstone do not function if they have a water block in the vertical column directly above them. And something tells me that a random pillar of glass blocks in the middle of the ocean is going to be rather conspicuous. So unfortunately, oceans are off limits. Of course, none of this really matters if you decide to simply build the cannon in the sky. If you decide to do this, keep in mind that if you build the cannon too high, then the payload won't be able to reach the ground. And then there is also the possibility of somebody flying into it at Mach 1 and griefing it to high heaven. Another amazing feature of the new design is that the payload duper, through the acceleration chamber, all the way to the payload magazine, is completely flooded with water, which means that loading the cannon prematurely will no longer result in a catastrophic explosion. This should hopefully mitigate the occurrence of situations like...
No.
However, keep in mind that these protections only apply in the situation where the cannon is already functioning within its own chunk loading envelope and then gets loaded by a player. If the cannon is running and the game stops completely, there is simply no way to guarantee that the alignment system doesn't fail when the game restarts. So unfortunately, there are fundamental limits to how much I can explosion proof the design, and you will just have to be cautious about running the cannon under conditions where the server might crash or restart. But the fact that the cannon can survive being loaded by a random player flying overhead is a compelling point to justify building the cannon closer to its target to capitalize on the faster charging times. Although just be aware that every time this happens, you will lose the shot the cannon is charging, meaning if it happens too often, your cannon will effectively be unusable. Let's say hypothetically we want to build the cannon on the Wavetech SMP. Here is a map of the Wavetech server. Note how the population of the world is concentrated around the spawn point, then spreads out with distance. This is a common pattern for any multiplayer server. Where we build the cannon will depend heavily on how we prioritize stealth over speed. At very short ranges, the speed of the cannon becomes limited by the speed at which the cannon's subsystems can communicate using redstone. These ranges are also dangerously close to being in render distance of any target. Around 10,000 blocks, the acceleration stage begins to dominate the time between shots, and will increase by about a minute for every 1,000 blocks. At 100,000 blocks, the charge time starts to exceed the hour mark, and the maximum range of around 258,000 blocks, you could be waiting up to 2 hours and 45 minutes for each shot. To help with our decision, let's just ask ChatGPT for a set of coordinates. Note that I am asking specifically for coordinates that are divisible by 16. This is extremely important. On a created single player copy of the Wavetech seed, let's teleport to those coordinates, and what we find is a big flat biome with lots of grass. It's not ideal, but we can't be too picky about where we build. Plus, it's in that 1,000 to 10,000 block window that is ideal for firing speed. And as an added bonus, there are barely any caves with fluids that we have to deal with. The best way to start is with a creative copy of your world seed, as this will allow you to test and fine-tune the parameters of the design to your specific use case. Let's just make sure that we are at the coordinates that we selected. Let's go ahead and load a schematic of the orbital strike cannon. Here it is, the schematic of the new and improved orbital strike cannon. With schematic subregions rigorously defined to minimize the amount of digging required to fit the machine underground. In Litematica's configuration menu, you should be able to find the option called Tool Item. This normally defaults to a stick if you've only just installed Litematica. However, I've set my tool item to a wooden axe so that it's consistent with World Edit. If I go ahead and grab a wooden axe, a menu will pop up in the bottom left hand corner which shows me a bunch of information about the schematic. If I hold down Control and then move my scroll wheel, I can bring up additional menus. If I go to the menu Edit Schematic, I can then go back into Litematica's configuration menu, go to the Hotkeys tab, and if I go down to Schematic Edit, there are all these options to actually edit the blocks in the schematic. So I want to set up a hotkey for Schematic Edit Replace All, like so. And now, here's a really neat thing I can do. If I grab a block like stone, and I look at all of the white concrete blocks, I can hold down the newly assigned hotkey for the Edit Replace All. And now, if I right click, every single white concrete block in the schematic has been replaced with stone. If I wanted to save my block substitutions to a new schematic, all I need to do is go to the Lotus schematics, save to file, and I can create a new variant of the schematic with all the white concrete replaced with stone. If I didn't care about stealth and I just wanted to build the cannon as quickly as possible, I could simply build the cannon right here above the ground. However, if you want to build the cannon underground and make use of the trapdoor, you want to go into the schematic first and see how there's all of these subregions. If we disable all the subregions and then scroll down to the subregions titled trapdoor, we can enable all of these subregions to only show components contributing to the trapdoor in the schematic. Let's now nudge the schematic down until our trapdoors are embedded inside of the terrain. There we go. They line up perfectly with the terrain. Assuming that we're setting this up in creative for testing purposes, I'm just going to go ahead and hit the execute operation keybind, which can be found under execute operations. So I have it bound to my G key. There we go. We've just pasted in the trapdoor inside of the terrain. Let's now go back to the schematic, re-enable all the subregions, and then disable the subregions for the trapdoor. This leaves us with the rest of the cannon that we want to build somewhere underground. And what we want to make sure is that we go to configuring the schematic, placement origin. We need to make absolutely sure that the X, Y, and Z coordinates are all divisible by 16. So right now the Y coordinate is 20. This is not divisible by 16. So we have to move it to a coordinate that is divisible by 16. And then the cannon will be properly chunk aligned. From here, we can hold down the shift key and then nudge this value up by multiples of 8. So 2 of these nudges is a whole multiple of 16. 0 is a great Y coordinate for the cannon because it places the majority of the cannon systems just above the transition from stone to deep slate, meaning the majority of your excavation can be instant mined through stone. With our schematic origin properly chunk aligned, we can go ahead and paste it in, seeming that we're just setting up for creative. And now we need to make sure that we connect the clearance for the magazine, which is this tunnel right here. There we go, we've now got clearance all the way up to the trapdoor. We also want to make sure that our daylight sensors have their clearance right here. There we go. And finally, there is a wire connecting the trapdoor to the chunk loading detector. So here's the chunk load detector, which is just a chest minecart activating a pressure plate. Now we want to make sure that this limestone connection goes all the way to the top. So we want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. It's now connected. Let's just make sure that it's working. Yep, it's now able to operate the trapdoor. For the trapdoors, we want to make sure that the materials at the surface match the materials of the surrounding terrain. Let's also shape the terrain a little, just to make sure that it's not too obvious that the terrain has been modified. Same for our daylight detector trapdoor. And just for good measure, let's go ahead and plant some trees around the trapdoors to help with concealment. Just keep a note to make sure that the clearance above the magazine is maintained. The next step is to set up the chunk loaders. So a neat trick is to grab the coordinates of the origin of the overworld side of the cannon and simply divide those numbers by 8, which gives us 724 and 148. So if we go through to the nether, we can then set up a schematic for the nether and move the schematic over to those coordinates, like so. Now here's the neat thing. The receivers for the chunk loaders on the nether side are extremely simple. All you need is a portal next to a fire block. And by positioning them as close as possible to the relative origin of the cannon in the overworld, we can apply a really neat trick. If we set up a random portal above where the cannon is hidden, now, if a player just happens to build a portal nearby to where the cannon is in the overworld, these portals will link to this portal above the cannon, leaving no trace of the cannon's chunk loaders. This should mitigate the risk of players randomly teleporting to the cannon's chunk loaders from the nether. With the nether side receivers active, we can now activate the chunk loaders. If we go up into chunk debug, we can see that now the area is being chunk loaded automatically. Before you leave the area, you also want to make sure you disable this lever right here, so that now the wireless redstone receiver is active. If I simulate the player leaving the area by disabling chunk loading, the trapdoors are opened. Oh, I might have screwed up something with the schematic. Okay, that can't be a thing. As I was saying, the trapdoors are opened. There we go. And the wireless receiver is now active. When my player returns and starts loading the area again, yep, the trapdoor's closed and the cannon is concealed. Once you've established where you want to build the cannon, there are a couple of tricks you can use to make placing the blocks in survival much easier. You will of course need to use Litematica for the schematic. I am not doing a block by block tutorial for a machine this complex. It's completely pointless. The tutorial would go on for hours and nobody would be able to follow it. Trust me, use Litematica, it will save you a lot of trouble. You will want to start with the material list, which Litematica has a feature for. All you have to do is go to the schematic, click on material list, and just like that, you have all the materials that go into the design. Litematica even has this neat info HUD, which you can enable to display a material list which updates as you gather materials. However, this list only includes blocks that you physically place. It does not count entities such as this chest minecart or the contents of containers. In addition to the material list, you will need 18 boats, 17 chest minecarts, 3 hopper minecarts, 2 stacks of iron blocks, 3 stacks of moss blocks, 68 of each music disc from disc 13 to style, and about 40 stacks of some arbitrary dummy item. The boats are found inside of the chunk loaders. The chest minecarts are used for chunk loading detection, as well as a storage device for the disk encoded memory. Hopper minecarts are inside of the chunk loaders. The hopper minecarts have very specific alignments, so for example, with the chunk loaders, you want to place all the blocks first, and then roll the hopper minecart into position using a powered rail like so, before then lighting the portal. And now you have the hopper minecart for the chunk loader, and a similar situation for this hopper minecart in the jukebox sorter, where you'll have to place the minecart on this rail here, and then push it into position against the iron trapdoor, like so, and then the hopper minecart underneath the jukebox will be properly aligned. The iron is used to craft shears, which I use as an arbitrary unstackable dummy item. And moss blocks are used to set the fill level of composters. The music discs are used in the disk encoded memory. And finally, our arbitrary stackable items can be found in various droppers in the wireless redstone. The best practice for setting up your schematic is to render it in layer mode. I normally use all below so I can see all the blocks below a certain Y value, and I can move the Y value up and down. I can also set it to where my player currently is. I also make use of a hotkey called layer set here, which means I can quickly set the current layer to where my player is standing while I'm building. On top of this, you can also use page up and page down to quickly move where the schematic layer is. The reason why it is best to use layer mode is that you can see an entire plane of the schematic at once, which makes the schematic much easier to follow. I even went as far as placing extra blocks to ensure the player can practically access every system from the bottom of the cannon to the top by simply walking and jumping. Now that we've established where the cannon is and how to use Litematica to build it, let me show you how to interface with the cannon and give it firing instructions. Previous orbital strike cannons used decimal encoded counters where the inputs were stored as signal strengths ranging from 0 to 9. The new cannon uses binary encoded counters, which are much simpler to build. Just looking at these devices side by side, and you can see a stark difference in the build effort and complexity. This reduced complexity does however come at the cost of information density. The decimal counter can store up to 10 million counts, while this 15-bit binary counter is limited to 32,768 counts. However, let's consider the fact that even when limited to 32,000 counts, our cannon goes up to ranges of 250,000 blocks, taking almost 3 hours per shot. With this in mind, the decimal counter's 10 million counts is very much overkill, especially given it would extend the range of the cannon to almost 100 million blocks and take almost 30 days in real time to fire a single shot. So I'd say the downgrade is fair enough. Just like with previous designs, the acceleration stage works with batches of 10 TnT, and considering the blast efficiency of each acceleration count, what we get is roughly 7.8 blocks of displacement for each one of our counts. We have 15 bits dedicated to the counting of our TnT batches to bring our payload close to where we need it to be. Then we have 4 bits defining the amount of TnT in the final batch to hone in on the exact block position of our target. And we also have this additional bit which allows the axle duper to flip the direction of the applied motion to enable omnidirectional firing. We have adopted the 2-stage acceleration concept from the Hellstorm cannon to enable both axes to run simultaneously without one axis affecting the other. The result of this system is perfectly linear acceleration in each axis. Here is a skeleton of all the binary encoded systems needed to deliver a payload to a target. We first have 1 bit to specify whether it's a nuke or a stab charge. We have counters to define the size of the nuke or the depth of the stab charge, and these will control the counter that builds the payload and duplicate the specified amount of TnT for the size of the specified payload. We of course have our 15-bit counter for the acceleration axis, plus the 4 bits of trim, plus the additional bit for the direction, multiplied by 2 for the second axis. And on top of that, we have this 5-bit counter for the vertical Y direction, as well as 4 bits for the trim in the Y direction. That means a single firing instruction is a 55-bit sequence. This is a problem because I want to use binary encoding with wireless redstone to communicate with the cannon. And this is what a 17-bit sequence looks like with current wireless redstone technology. It's not even half the byte size needed for our cannon, and it's pushing the limits of what wireless redstone can do. To transmit a full 55-bit sequence, we'll need to chop it up into many smaller sequences and transmit them one by one. However, there is a slight issue with this particular wireless receiver. Because it outputs on many channels simultaneously, in the event that the receiver is unloaded while it's running, and is then loaded, it will always output a random binary sequence every time it's loaded. This would mean every time the game restarts and the cannon's chunk loading starts, there is a chance that a random binary sequence will get uploaded to the cannon and will cause the cannon's systems to become corrupted. So I had an amazing idea. If we're going to need to cut up the binary sequence into many smaller sequences, why not go all the way? What if instead of trying to read an entire sequence at once, we simply split the binary sequence into individual bits spread out over time? Let me introduce the wonderful world of serial binary encoding. The 20 game tick cycle from our daylight sensor feeds into a single tile set, which is then split into 5 signals separated by 4 game ticks. This effectively gives us a 5-bit sequence which can be repeated every 20 game ticks. Activating only the first bit will give us only a single pulse coming through every 20 ticks. Activating 2 bits will give us 2 pulses every 20 ticks. And activating all 5 of the bits will give us a continuous 4 game tick pulse. In order to transmit a large binary sequence, I've gone ahead and made this terminal which squishes the binary sequence into 2 dimensions, making it easy to configure. We can then transmit slices of this terminal every 20 game ticks and reconstruct the signal at the receiver. In order to make the wireless receiver robust against being unloaded and loaded again, the first 10 bits of any binary sequence coming from the receiver must perfectly match a passcode in order to unlock the machine. And because our wireless modules are all activated at different times, it's possible to find specific passcodes that will never be accidentally triggered by a loading event. I stress test the wireless receiver for over 10,000 cycles of being unloaded and loaded to find these specific passcodes that never misfired over those 10,000 cycles. Oh, and of course, just like previous designs, we have an Excel spreadsheet which essentially gives us a QR code to punch into the control terminal for a specified target. Any one of these passcodes can be selected at random, put into our spreadsheet, and then used as a unique passcode for our cannon. You can then configure the passcode on the receiver using this sequence of lamps. Then if we go ahead and reset the passcode gate, like so, we can transmit to the receiver. And if the passcode matches perfectly, it will then send an activation signal to the cannon. The control terminal has many cool features, and in order to make effective use of all of them, you'll need to make sure that it's properly chunk aligned. The amazing thing about this terminal is that you can build it anywhere in the overworld, and provided the Orbital Strike cannon is being actively chunk loaded, you will be able to communicate with it over any distance. But that's where we encounter a problem. After having just started this world, the chunk loading tickets for the Orbital Strike cannon's chunk loaders were lost, and therefore are nowhere to be seen. You will need to go to the physical location of the cannon in order to make sure that the chunk loaders are restarted. In 1.21.5, we can look forward to this new change, which would allow the chunk loaders to start automatically each time the server reboots. In theory, since 1.21.3 allows ender pearls to load chunks, you should be able to use ender pearls to kickstart the chunk loading each time the world restarts. However, this embodies the risk of players being able to find your cannon and exploit the ender pearls you left at the cannon to force you into a trap. They're probably not the best thing to leave lying around next to a weapon of mass destruction, but provided the cannon's chunk loaders are online, inputting settings through the terminal is pretty straightforward. From the spreadsheet, you'll want to start by picking a random passcode if you want to have a unique passcode to access your cannon. And after inputting this to the passcode field, you'll want to configure this on the receiver of your cannon. You also want to go ahead and input the origin, which in our case is 5792.0.1184. You can then select the target coordinates like 2000, 2000, the height of the terrain at that position, which we can just guess and say 60. You can select the type of payload to be a nuke or a stab charge. You can change the depth of the stab charge or the size of the nuke. And the spreadsheet will even give you a pretty accurate estimate of the amount of time in hours, minutes and seconds for the shot to be fired. If you mess around with the spreadsheet a bit, you might find that warnings will often be displayed. These warnings are to ensure that you do not damage the cannon or potentially harm the server that you're playing on. For example, nuke sizes above 16 have an enormous amount of TnT and could lag the game during the acceleration stage. Other warnings include when the target is out of range, when the target is too close to the cannon, when the target is too high up in the sky or too low in the world, when you accidentally don't specify any settings that will create a payload, or if you specify a passcode that's not one of the safe passcodes that were tested extensively. Just make sure that you pay attention to the warnings and don't do anything silly with the settings for your cannon, otherwise you may be disappointed at the results. Going over to our terminal, we want to ensure that the lamps match the pattern given to us by the spreadsheet. Once the pattern matches, you can go ahead and start transmitting. And then the binary sequence gets sliced up into its 5-bit segments. And that tone indicates that the cannon has successfully received the signal, and this lamp flashing indicates that the cannon is currently working to build your payload. When the lamp stops flashing, you'll promptly hear, pizza's ready. So now if we teleport to the coordinates that we specified, oh, yep, that is definitely a stab charge. And that is pretty much exactly on top of 2000. So the cannon is deadly accurate. Another amazing feature of the cannon is the magazine, which can hold up to 8 payloads meant for different targets. A second wireless receiver is used to control the magazine from the control terminal. Triggering a slot of the magazine will lock that slot from auto-firing when the cannon has finished building a payload. If I go ahead and disable one of the slots like so, and go over to the magazine, the payload corresponding to that slot gets fired. If I go ahead and disable all of these, we'll fire every single slot. Payloads are loaded into the magazine sequentially. So the first payload you input will move towards the end of the magazine. And you might notice that this changes the starting position of the payload. To compensate for this, the spreadsheet includes this magazine payload slot number, which you can use to account for its position in the magazine. And this ranges from 0, which is the first slot, to 7, which is the final slot. The reason why the magazine is set up this way is that I wanted to allow players to choose which magazine slots to trigger at any time. Of course, in order to fire the magazine slots independently, you will need a player present at the terminal to hit the buttons. However, if you want to be a part of the action, you can also use this port for a fishing rod to create a portable wireless trigger for the magazine. To set this up, you'll want to start by pulling this lever to suspend all auto-firing. And then you can send fire instructions to the cannon one by one. Make sure you wait until you hear the confirmation tone before trying to send new instructions. When you want to finally leave the area, you will pop the fishing bobber into this port like so. Then you can switch off the lever and carefully exit through the chunk loading portal. If we go to the coordinates of the target, my fishing rod is now linked to the control terminal, which is sending instructions to the cannon to suspend auto firing. In order to use the fishing rod trigger, you need to make sure that your control terminal is only being loaded by its own chunk loader and there aren't any players nearby. Because if a player were to suddenly load the control terminal, it would also load the fishing bobber and it would realize that it's not in range of my player and remove itself, causing the cannon to fire prematurely. Assuming the cannon has finished building and accelerating your payloads, all you have to do now is reel in the fishing rod, and in about a second the cannon will fire. There's our payload, and it's causing us a lot of FPS lag. But sure enough, the remote trigger works. The way I've designed the wireless redstone allows for multiple receivers to run simultaneously in the network. So for example, if I go ahead and copy all of the wireless mechanisms for the cannon, any instructions sent from the wireless terminal will be reflected in both systems running simultaneously. This is great because you can have multiple cannons with different passcodes and then communicate only with the cannon that you use the correct passcode for. However, that also creates a problem if somebody else has built the same cannon somewhere else on your server, because their control terminal can be used to effectively jam any communications to any cannons with the same wireless redstone. To fix this problem, you can use these 3 repeaters at the end of each tileset to make a new isolated wireless network. So by default, they'll come in the sequence 2, 4, and 6. Let's change this to something else, like something like 4, 6, and 2. And we'll need to make sure that we copy this to every single tileset in our network. So we want to make sure all of these are the same. We want to make sure it's 4, 6, and 2 on these repeaters on the receiver. There we go, 4, 6, and 2. We also want to go down here. 4, 6, and 2. Down here. 4, 6, 2. And inside of the transmitter, make sure all of these are the correct ones. Yep. We'll also need to change these repeaters. 4, 6, 2. As well as the repeaters inside, right here. So it's a bit of an involved process to swap all of these repeaters. However, there isn't really an easy way to implement this. With all our wireless systems now set up on our new isolated network, we can go ahead and restart the transmitter and the receiver. And now, the slots corresponding to our control panel are active on our new receiver and aren't being triggered by the default receiver. If we send firing instructions into our new network, yep, they're being received by our isolated receiver and are not being received by the other receiver. Hopefully you won't ever find yourself in a scenario where people are trying to jam your wireless communications with your cannon, but it's certainly a possibility, so having this added flexibility might be necessary. With an understanding for how the wireless redstone works, let's have a crack at understanding the serial encoding process. I've gone ahead and added in the wiring for all the binary code systems and color coded the wiring to explain how it all fits together. It all starts with the wireless receiver listening into the ether for signals. And if a signal just happens to begin with the correct passcode, then it's guaranteed to be firing instructions. And so the cannon will start transcribing the binary sequence to the cannon's hardware. The really neat thing about serial encoding is that a single wire can carry all 55 bits spread out over time. This makes transporting the signal around using spaghetti wiring significantly easier. Once the settings are transcribed, the cannon starts doing its thing and using the settings to build a payload. However, this takes a really long time, and the player might want to upload additional targets while the cannon is busy. In order to schedule additional firing instructions, we introduce an RWM or read and write memory. We can then switch the connections from the receiver over to this memory to schedule additional targets while the cannon is busy. When the cannon is done executing its previous instructions, it will receive its next instructions from the memory. And because our inputs and outputs from the RWM are separate, we can even perform read and write operations at the same time. The memory uses music disks to compress the 55-bit sequence down into just 19 container slots of a chest minecart. These minecarts can then be stacked together for storage density and accessed again through entity separation. So performing the readout, we pull out a chest minecart, and then we start sorting the music discs using a jukebox sorter, and they are sorted into their respective slots. Our music discs are assigned numbers from 0 to 7, which gets read out as a 3-bit binary sequence. This 3-bit sequence is then separated out into 4 game tick pulses, which reconstructs the entire 55-bit sequence we use to program the cannon. What we end up with is a robust architecture which enables us to interface as efficiently as possible with the cannon from anywhere in our Minecraft world. You might see this and think, geez, wasn't it a lot easier when you could just punch in a bunch of settings and then leave? But I can assure you, this process does simplify things a lot. With previous cannons, you would actually have to go to the location of the cannon in order to give it firing instructions. But the wireless serial encoding completely eliminates this constraint. You can build several of these transmitters around your world, making it inconsequential whether somebody follows you to a single transmitter. Destroy one transmitter, and another will take its place. The wireless communication also greatly simplifies the interface, as now you get consistent feedback from the cannon. In the previous design, you had to mess around with various items, item filters, and decimal encoded counters. It was an absolute mess. The elegance of being able to simply throw complex instructions into some invisible ether and have them materialize inside of a redstone contraption is an absolute marvel of redstone's capabilities. Which is what I love about this game, the fact that it's not magic, it is just a rigorous application of the game's mechanics to achieve a desired outcome. And nowhere is this more the case than in the construction of the TnT warhead. Ever since the 2.0 version, we have had this programmable warhead builder. It made the design extremely flexible by customizing the shape of the TnT warhead. We could create nukes, depth charges, bunker busters, and one of my personal favorites, the Power Christ Compels You. This device was a jack of all trades, effectively a breadboard for customizing the warhead. But what it offered in flexibility, it sacrificed heavily in efficiency. It's slow, bulky, and cumbersome to configure. Which is why in the new cannon I have opted to go for a mechanism that is primarily optimized for building the nuke and the stab charge. This made it possible to incorporate more control in the size of the nuke or the depth of the stab charge. Some of you might be disappointed about losing the ability to make crazy warhead configurations, however I just haven't seen many people doing it. And besides, all you really ever need are the nukes for area of effect and the stab charge for ground penetration. More sophisticated warheads require tons of TnT, which just end up lagging your game to death. The new TnT warheads have some amazing features which make them even more effective than similar warheads fired from older designs. For example, we now have variable height for the payload, which means we can precisely control the distance that the payload falls in order to optimize the resulting explosion. The stab charge can be tuned to penetrate a certain distance through the terrain, and the nuke can be tuned to airburst above the ground with a specific radius. The warhead builder has two TnT dupers, a larger duping array for quickly growing the warhead yield, and a smaller precise duper for shaping the warhead. Let's look at how we build each payload in detail to understand how to use them most effectively. The stab charge has 3 stages. The first stage provides a kick to push the warhead to a high enough speed to avoid the effective swing. The second stage provides the bulk of the downwards acceleration, and the third stage is the penetrator warhead that makes contact with the ground and punches a hole. Swing is a really annoying effect which is caused by TnT moving and exploding within range of other TnT moving in the same direction. And it most commonly affects TnT falling due to gravity. In this exaggerated case, we can observe that the TnT swings up and down with this sort of asymmetric oscillation. Swing is super inconvenient for us because we want to accelerate our warhead downwards as efficiently as possible. But with the most simple case of using only 2 stages, we can observe a displacement of only 24 blocks using 100 TnT. That is a blast efficiency of only 24%. If we have a look at the Y values of all the down accelerating TnT, we can see that the values keep changing. This is the effective swing causing our down acceleration charge to oscillate back and forth, which greatly reduces the efficiency of the downwards acceleration. But watch what happens if we dedicate just 10 TnT to providing us with an initial kick to our downwards acceleration. All of a sudden, we are getting a displacement of 72, a 72% blast efficiency. We are still using exactly the same amount of TnT, however, by just having a batch of TnT that explodes 1 game tick prior to the main down accel charge, we can greatly reduce the swing and increase the displacement of our penetrator warhead. 72% is pretty good, but with a bit of clever tweaking, we can go even higher. Here is the configuration we use for the new and improved stab charge in the latest orbital strike cannon. A whopping 99% blast efficiency for downwards acceleration. The way we achieve this is by having 9 TnT with fuses from 1 to 9 give the initial kick over multiple ticks, which completely eliminates swing and extracts the maximum possible acceleration from every single TnT. And it also creates this cool effect as the stages detonate each tick, giving this staggered explosion. The stab charge will maintain a constant altitude relative to the target position you input. This is sufficient to dodge collisions with any natural terrain and most tall structures. The target position is ideally set to the position of the ground. You can also control the depth of the warhead. The depth setting can reach values of 279, which is excessive for most cases. Just keep in mind that the depth is always relative to the position of the target. The new nuke warhead has also received some major upgrades. To understand how we can improve the nuke, let's break down how the warhead works. The nuke warhead is constructed using TnT prime momentum, which is the little jump TnT does when it is ignited. Prime momentum will pick a random direction and set the TnT's initial motion to a magnitude of 0.02 blocks per tick in that direction. The randomness might make this mechanic seem pretty useless, but looks can be deceiving. Over very many TnT ignitions, the prime momentum will begin to trace out a perfect circle with a radius of 0.02 blocks per tick. Now with our lazy acceleration cannon generating TnT inside of lazy chunks, this means the TnT will retain its prime momentum all the way through the acceleration stage to the launch stage. So the ring shape is maintained all the way to the target position, causing the warhead to be a little bit chonky. If we add some TnT without the prime momentum so it explodes perfectly in the center of the ring, it will expand the formation into a circle of death. While a perfect circle of TnT raining from the sky might intimidate a lot of people, it's not very effective for destroying a large area, but it's certainly a step in the right direction. The problem is that we're only getting one ring with a set radius, so what we need is different rings with different radii. Notice how this bottom command block gives us 100 TnT with the prime momentum and max fuse time of 80. The second command block gives a single TnT with a much shorter fuse time to expand the ring before it explodes. This command block at the very top is one we haven't used yet, which is just 9 TnT set to explode exactly 1 game tick before our ring expansion charge. If I go ahead and disable anti-ticking, and then create a couple of ring charges along with their ring expansion charges, and then I add in this one on top of the bunch, like so. Start entity ticking. Watch what happens. Multiple rings with multiple radii. To create the rings of TnT radiating out from the center of the warhead, the payload builder will create a ring charge, then add an expansion charge which expands the radius of that ring. It will then make another ring charge, then add another expansion charge, and each expansion charge will also contribute to the expansion of the rings made prior. So repeating this process a couple of times, and you end up with a pattern of TnT radiating out from the center of the warhead. But here's where we can spot an opportunity to make some improvements. Notice how as the radius of the ring grows, the density of the TnT decreases and thus gaps will appear. This means we need more TnT in the larger rings to maintain the integrity of the ring shape, but using that same amount of TnT in the smaller rings causes the TnT count to grow by the radius squared. We can make a change to this process, which means the amount of TnT we add to the ring is proportional to its radius. Comparing this new method with the old one, and we can observe the new method finishes building its payload in about half the time and thus uses only half the amount of TnT. We can replicate this mechanically by placing two binary counters in series. The first counter stores the radius number we input for the size of the warhead. Then the second counter reads the first counter and dispatches that amount of TnT into each ring. This is the advantage of having a dedicated mechanism for building the warhead. In the previous design with the variable warhead builder, the counters which determine the amount of TnT in each ring couldn't change during operation, which results in the nuke being terribly inefficient. With this new design, however, we get roughly twice the performance for the same size warhead, which is pretty significant. Controlling the height of the warhead is also helpful to improve the performance of the nuke. The nuke will hold a constant relative distance of about 140 blocks from the target position, which is high enough to clear most obstacles. The nuke's warhead will deal damage over a large area. The diameter of the nuke's effect scales by a factor of 12 with the nuke size setting, which means the largest setting of 31 will be 372 blocks in diameter. The height of the nuke's blast zone is finely tuned to start 3.2 blocks above the target position, but due to the dynamics of how we build the warhead, it will slope downwards as the rings expand by a factor of roughly 0.3 blocks. This means there may be a bit of guesswork involved in getting the explosion to behave the way you want depending on the conditions of the terrain. A lot of people are wondering if you can use the cannon to make perimeters. I did try making a cannon dedicated to perimeter excavation, however it was simply too performance intensive to run on any server without lagging the game to death. So unfortunately making perimeters is not really practical using lazy acceleration cannons.
Nuh-uh.
The fuck do you mean nuh-uh? So, turns out on Wavetech we literally use the orbital strike cannon to make circular perimeters. How the hell is this even possible?
Well, turns out the secret sauce to making the orbital strike cannon into a perimeter cannon was to explode the TnT in mid-air. And then, every subsequent shot, we would release one block lower and lower and lower to gradually mine out a perimeter, like a regular world eater.
So I guess you've turned a weapon of mass destruction into an actual utility.
Well, it's still a weapon of mass destruction, it's just nicer to look at.
Controlled demolition.
Yeah.
Turns out the problem with making perimeters using the orbital strike cannon was mainly due to the fact that the nuke would spread too early and sink into all the nooks and crannies of the terrain before exploding. This would make the excavation utility of the warhead extremely unreliable. So what JKM did was tune the warhead to deploy much later such that the TnT would explode just above the ground, which would give it a much more consistent coverage. The reason I never thought of this was because I was always testing a nuke on perfectly flat creative worlds. If I had forced myself to test a nuke on worlds with naturally uneven terrain, I would have realized this oversight. This goes to show that insight often comes with unique experiences, and machines should always be tested in environments which match the parameters of their applications. If you want to learn more about Wavetech's perimeter cannons and various other projects going on, be sure to give JKM's new Wavetech recap series a watch. I believe he'll be posting another video soon for the month of February. Speaking of videos posted at the end of February, today is the 2nd year anniversary of the original Orbital Strike Cannon Mark I. What a fitting end to this video. It has been a wild ride. In hindsight, I really should have put more effort into the production of those videos. Leaving out crucial details on one video to then bring up those crucial details in another video led to a lot of confusion and frustration to people who viewed the cannon's development out of order. So let me take a moment to say that I want to apologise for any hardships people may have experienced when trying to get the Orbital Strike Cannon to work off of the limited information I would provide about the design. And I hope with this video that I can redeem myself with the latest and most ultimate Orbital Strike Cannon. Thank you all very much for watching, and I will see you next time.